Hello friends, today's video is related to why planets spin and what if they don't spin. Planets actually spin because of inertia. In the vacuum of space, spinning objects maintain their momentum and direction because no external forces have been applied to stop them. When planets form from a collapsing cloud of gas and dust, the rotation of the cloud is conserved, which is why all planets rotate in the same direction. The force of gravity causes the planet to spin faster, and rising pressure in the core causes the core to melt. Denser materials sink toward the core, and lighter materials float to the planet's surface. This process is similar to how an ice skater spins faster when they pull their arms in. As their arms come closer to their axis of rotation, their speed increases and their angular momentum remains the same. Similarly, their rotation slows when they extend their arms at the conclusion of the spin. As an interstellar cloud collapses, it fragments into smaller pieces, each collapsing independently and each carrying part of the original angular momentum. The rotating clouds flatten into protostellar disks, out of which individual stars and their planets form. By a mechanism not fully understood, but believed to be associated with the strong magnetic fields associated with a young star, most of the angular momentum is transferred into the remnant accretion disk. Planets form from material in this disk, through accretion of smaller particles. In our solar system, the giant gas planets, Jupiter, Saturn, Uranus, and Neptune, spin more rapidly on their axes than the inner planets do and possess most of the system's angular momentum. The Sun itself rotates slowly, only once a month. The planets all revolve around the Sun in the same direction and in virtually the same plane. In addition, they all rotate in the same general direction, with the exceptions of Venus and Uranus. These differences are believed to stem from collisions that occurred late in the planet's formation. Now, if a planet were to stop spinning, it would have a number of consequences. The atmosphere would continue to move at its original speed, causing everything not attached to the bedrock to be swept away. The day and night cycle would be altered, and seasons would become more extreme. The oceans would move towards the poles, and the magnetic field would disappear. In the highly unlikely event that a star or solar system has no angular momentum and therefore no spin, the result would be a non-spinning star without any orbiting planets. Thanks for watching the video.